All right, so we'll move on to today, and we'll be talking about encapsulation in further detail, which is what I mentioned earlier, and just why we do it, what it is, and how it applies to classes. So there are a couple of different things we'll talk about today. These are just tools at your disposal. I'm not saying you necessarily have to use them, but they are at your disposal, and I want you to know what they are. So again, classes act as a template for objects. Okay. With a class, we can declare common attributes. So if I have an athlete has a name, an athlete has a height and a weight. That's common across typically most athletes, right? And for our purposes as programmers, that'll be common for the objects we create, the athlete objects we create. We can provide methods to access those attributes. So we had those getter methods and those setter methods, right? Get mate, set mate, get model, set model, or for the athlete, get name, set name, get height, set height. We have all those methods. And we can include specific logic that applies to each object. So for example, when we convert height in inches to that string, that's specific logic that applies to every athlete, right? So we can add all of that in our classes. And in our main, when we create an object of that class, we don't have to worry about all that logic. It's already handled in our class. So what if we want all of our objects to share a variable, one single variable, or however many we want, one or more variables? We can declare that variable as static. So what that means is when I create a class, that variable is statically created when I start the program, right? Each object does not get a unique copy. All objects will share that copy. So I think I have an example. So in other words, let's say I want to keep track of all the athletes I have. And so when I create a new athlete, I obviously add 1 to the number of athletes. If I want to do that, I can create a static variable. So each time I update that variable every time I create an athlete. So when I create my first athlete, that variable becomes 1. When I create the second one, 2, 3, so on and so forth. And I'll show you what I'm talking about with the visualizer. Again, in order to do so, we use the static keyword. And also in this class, we probably won't use static a whole lot. But again, I'm giving you this tool at your disposal. The static keyword specifies that the member belongs to the type itself. Basically, it belongs to the class, not the objects that were created from the class. Okay. And let's do an example. And I'm going to use the athlete class because I already wrote the program for it. So I'm just going to copy and paste all of our code from athlete into the visualizer. All right, so I have all of this in here from NetBeans. It has all the good stuff. I don't need this package because this is not in a folder. And I'm going to create a main method, public static void main string args. Again, the visualizer, I can't do this in a separate file, so I'm just going to do it all in one file. And I'm going to create an athlete object. Athlete, I don't know, KD equals new athlete. I'm passing Kevin Durant. His height is like 1 billion feet. I don't know, what is it? What is 6'11"? 72 plus 11 is 83 inches. And then his weight is supposedly 245. All right, so when I create this athlete, right, I expect those variables to have that, those values. So system.out.println KD dot get name. Actually, let's do get height. So I expect it to say 6'11" if everything goes correctly. So let's visualize this. So we're right here in our main. We step forward. We create the Kevin Durant or KD object. And it's going to set all of our attributes equal to these parameters. So again, right here, when I say new athlete, it calls our constructor method, passing in these parameters. Right? So name is Kevin Durant, weight is 245. It's going to call our convert height method, passing in that height. We're going to do feet equals 6, inches equals 11. This dot height equals 6'11", right here. And the escape character, it messed up, but we'll fix that in a second. I think I used the wrong character. All right. And we set KD equal to this athlete object. Kevin Durant, 6'11", 245. Okay. Cool so far? All right.
Yes, sir.
And then when we system.out.println KD.get height, it's down here. Oh, we're calling the get height method, so it's going to run this get height. It's going to return that and then print it out down here, 6'11". There you go. And see, the escape characters work because it prints out as 6'11". So the escape character is working as I had hoped. Okay. So that works. We create our KD object and whatnot. Let's say we want to create another object, but we want to keep track of how many athletes we have. So I can do a static, and it's similar to the main method. The main method is static. There's only one of them. So there's only going to be one of these variables, static int number of athletes. Now I'm going to set this equal to 0 up here. By default, it's going to equal 0. When it's created, it's going to equal 0. And now in my main, what I'll do is, every time I create a new athlete, I'm going to say number of athletes plus plus. So each time I create a new athlete, this will be incremented. And it's shared for all of my athletes. So let me create another one. Athlete Nadal equals new athlete. I'm going to butcher his name. I hope I spell it right. Nadal. I think he is roughly about 6'1", which is 73 inches. And I assume he's about 190. And then I'll do system.out.println Nadal.get height again, just to make sure it's right. And then I'll create one more athlete. Let's see. Watson equals new athlete. And I am making a mistake. Objects should always be lowercase. When we create objects, they should always be lowercase. Watson equals new athlete. Deshaun, I think I spelled it right. Watson. He is about 6'3", I believe, so that's 75. And I have no idea how much he weighs. Let's say 220. System.out.println Watson.get height. All right, so now, hopefully this compiles. Each time I create one of these new athletes, the number of athletes will be increased by 1. And again, that's shared by all athletes, okay? And look, literally the first thing that's executed is to create that variable, right? Even before we create our first athlete. Now we're creating our KD athlete, setting all of his things equal to those values, right? And we did number of athletes plus plus. Now number of athletes, which is a static field, is increased by 1. We do the same thing. We're printing out the height. When we create an adult, we're doing all of his stuff. Number of athletes plus plus. Now it's 2. Right? And see, number of athletes, it's associated with our athlete class, not one of these objects, right? These are objects, but number of athletes, you don't see that as part of these objects. You see it as part of the athlete class, okay? So what I can do, instead of doing all these system.outs, so I create these 3 athletes. How you access a static variable, you do system.out or whatever, you just do athlete dot whatever the variable name is, number of athletes, right? We're calling the class athlete using this variable and then the variable, right? We don't have to create an object in order to do it. So system.out.println athlete, that number of athletes. So I would expect this to print out 3 because I have 3 athletes. So visualize. I'm just going to jump to the end, and it does indeed print out 3. Right? Again, this is a static field. It only applies to the class as a whole, not all of our individual objects. We have all these individual objects over here, and you see that number of athletes does not associate with them. Okay? Versus if I did this, if I didn't have that static keyword, now this is a part of each athlete, okay? And I can't call this anymore, and you'll see the difference. I jump to the last. Now you see each object has a number of athletes variable, not the class, okay? It's no longer a static variable shared amongst them. And you see, for each one, it's only incrementing its number of athletes variable, not the class one. Versus this, if I make this static, now it's the class one. If I visualize this, it's a static variable now. Does that make sense? I know that was a lot. And again, if you have questions, let me know. Or if I'm not, clarifying it enough for you, what you can do is just static variable Java. And hopefully another resource can clarify it for you. Maybe they explain it a different way. And I encourage you to use as many sources of information as possible because, if you learn something one way, great. But if it requires you to look it up another way, that's fine as well. All right, so that's a static variable. Again, shared for all objects. So what is a constant? It is what it basically says it is. It's a constant variable. Once you create it, it cannot be changed. It's final. You cannot change it once you create it, basically. You use the final keyword in order to do this. The reason being is maybe you don't want this variable to change its value, but you're going to reuse it over and over again. For example, let's say the math library doesn't come with pi. So we would create a final double pi. We don't want you to accidentally change the value of this variable in your program, right? We want its value to stay the same regardless wherever you are in your program. So let's do an example of this. Let's say I have public class example in my main public static void main string args. Let's say I have int pi equals 3.14. And then I'm over here trying to use this number all throughout my program. I'm trying to, double, this should be a double area equals pi, and then I'm going to say r is 5 times 5. And then I'm saying double perimeter equals 2 times pi times r, which is 5. Right? I'm using this multiple times throughout my whole program. So I need pi's value never to change. I don't want somebody to accidentally go down here and say pi equals 3.15, and then I'm trying to calculate the area again, and my results would be wrong. So I would say final double pi. And now this line cannot be done. You can't change the value of pi. And actually, I'm getting this error because I don't have my brackets. I can't change the value of pi right here. See, cannot assign a value to final variable pi. I can't do this. Pi's value cannot be changed, which is good. It protects you as the programmer from mistakenly changing the value of that variable, all right? And this is really good for like strings. So I have final string, let's say I'm making products and manufacturer, I don't want that ever to change. So I would say Toshiba. I don't want somebody to accidentally say Toshiba's or something of that nature. I want the value of that string to never change. And that's what I would do. Now, just common programming syntax. When you do a final, you want to capitalize all of capitalize the entire name, okay, the entire identifier. And that's so that when you're using it throughout your program, if you see a word that's all capitals, you know it's a final variable. It's established somewhere in this program as final, and you should not change or even try to change the value of that variable. Okay? Clear on what final is and what it's used for. Okay, I'm going to assume you're good on that. Again?
Yeah.
Cool. All right. Again, if you have any questions and you don't feel comfortable asking me in class, we can set up, time during my office hours. I have office hours from 12 to 2, Monday, Wednesday, and Friday, and we could try to set something up to help you out. So that's a constant. Again, for constant naming, you want to capitalize the entire name. And usually you'll put a underscore right here in between last and name. All right, so let's talk about visibility. Why do we use public? Why do we use private? In this class, we're mainly concerned with public and private. You can kind of, right now in this class, ignore protected. It is used, I assume, in some programs. I've never used it, but I assume some people use it. So the public keyword, you can, as you've seen, we can use it on our classes. We use it on methods, but you also can use it on variables. Basically, a public class can be accessed anywhere in your program. So we go to NetBeans, right? We have this package right here, assignment 3 classes. Well, we can create a new package, Java package, and I'm just going to name this other package. And I can have classes over here as well. Other class, right? So this class is public. Since other class is public, from this other package, I can get that class. I can say other class object equals new other class, right? And all I have to do is import this. And you see it imports from other package dot other class. It goes to this other package, all right? Inside other class, I can have a public int other variable. I'm going to say public variable, right? This variable is public, meaning from my main, when I create this object, I can access it. Object dot public variable. I can call this. Now it's not doing anything. It's saying it's not a statement, but let's say int number equals this. I can call public variable, right? It's a public variable. Again, with a public method, public int get public variable, return this dot public variable. I'm sorry, didn't have that. From my main, I can call object dot get public variable. It's a public method. Basically, it's accessible anywhere in your program. If it's public, right? So public keyword, again, accessible anywhere in your program. For variables, I could say car.make, car.model, car.number of doors. I can call the car.getMake. I can create a automobile object because it's public. Public means it's accessible anywhere. So what about private? So private classes are not accessible anywhere. It's only accessible in the classes created. So public classes are technically considered inner classes. Why? Because they are declared inside of another class. So we have public class, other class, and I'm going to say class, inner class right here. I've created another class, right, an inner class inside of this one, which makes it private. And it can have its own unique objects or variables as well. Public int inner class variable, right? But I cannot in my main say inner class inner object, right? You see, this is not the right one. This is coming from com.sun. That's not the one I want. But that's because this inner class is a private class, right? I can't create an object of that in my main, right? It won't work. I can't do that. It's a private class. Only from inside here can I create an object. So I'm going to create a constructor. From in here, I can say inner class equals, or object, inner class object equals new inner class. Only from inside of the surrounding class can I create an object of this. Can't do it in my main. It's private. All right. That's a private class. Let's delete this. So same thing goes for a private variable. Private int public variable. So since this variable is private, I cannot call it from my main like before. I can't do int number equals dot public variable. I can't do that, right? Actually, let's do this. Let's keep this one public. Let's create a new one. Private int private variable. Right? So in my main, I can do object.public variable, no problem. But if I hit number 2 equals object.private variable, I can't access it, right? It's private. That's going to be an error. It's private to this class. Okay? Same thing goes for a private method. Like before, when I created that athlete class, I created a private convert height method. I don't want anybody else to use that method except inside of this class. So I made it private. I don't want you to be able to call convert height from the main. I only want to use it in this class, so I made it private. There's no reason for it to be public or publicly accessible. So when you have private variables like this, private int private variable, what you want to do is create a getter for it, public, and make that public. Get private variable, right? Which returns this dot private variable. What did I do wrong? Let's spell return. Return this dot private variable. Same thing. If you want somebody to be able to set it, you do public void set private variable. And I realize it's the end of class, so I'll pick this back up next time. But basically, we're talking about encapsulation here. And what we want to do in the future, and what your lab will be, is turning all of our variables into private ones, right? And only using these methods to access them, I'm sorry. And I'll explain why next time, all right? So again, if you have any questions as to what I'm doing or why I'm doing it, or if none of this makes sense to you, please email me and we'll set up a time, all right? I don't want you all to get lost along the way, because again, everything that we're learning now, later on, we will use in our future programs. All right. Well, that's it for today. So I'll see you on Wednesday.
All right, have a good day.
You too.